Example number 5.16, page number 600. This example is taken from the book Electrical Machinery, written by Dr. P.S. Bimbhra. In this example, we have to find out the operating power factor of alternator and its load angle. The synchronous impedance of the machine is given, and it is also given that this machine is the synchronous machine is a synchronous generator. The synchronous generator is connected with an infinite bus at rated voltage, and it is given that the steam input to the prime mover is increased till synchronous machine starts operating at rated kVA. So how to solve this problem? In this question it is written that the synchronous machine is connected to infinite bus at rated voltage. Rated voltage means the terminal voltage of the machine equals to 1. The impedance, synchronous impedance, is given as 0.02 plus j 0.8 per unit. You can make the diagram in this way. This is synchronous impedance and this is connected to the infinite bus. Here is the infinite bus, and this alternator is delivering current IA. The internal EMF of the machine is EF and the terminal voltage is V. It is written in the question that the machine starts operating at rated kVA. The kVA of the machine is defined in this way: the magnitude of the terminal voltage into magnitude of the armature current. It starts operating at rated kVA. Rated kVA means 1 per unit, and the terminal voltage is given as, the magnitude of the terminal voltage is given as 1 per unit. So you can find out the value of current. The magnitude of the current will be 1. Always the terminal voltage is taken as a reference voltage. For the reference I am writing angle 0. This internal EMF, it is written that the machine is synchronized with an infinite bus. The meaning of the synchronization is the magnitude of the internal EMF and the magnitude of the terminal voltage will be same. This is the meaning of the synchronization, and it is given that the machine is synchronized with an infinite bus at rated voltage. Rated voltage means the magnitude of the terminal voltage is 1, so it will be 1. Always in the case of the alternator, the internal EMF leads with the terminal voltage by an angle delta. What I want to say, in the case of the alternator, the internal EMF will always lead with the terminal voltage. You can see the phasor diagram. This is the terminal voltage, and internal EMF will always lead with the terminal voltage, and the angle between the internal EMF and the terminal voltage is known as the load angle, defined by delta. So you can write the value of EF in this way. The value of EF will be equal to 1 angle plus delta, because the internal EMF always leads with the terminal voltage. That's why I am writing plus delta. You can apply KVL in this loop, and easily you can write this equation: EF equals to V plus IA ZS. The value of EF is 1 angle delta. The value of the terminal voltage is 1 angle 0. The value of IA, the magnitude of IA is 1. And I don't know whether this machine is operating at leading power factor or it is operating at lagging power factor. I don't know, so I can assume anything. Let us assume that the machine is operating at leading power factor. So for leading power factor I am writing plus 5. So value of Z dash equals to 0.02 plus J 0.8 per unit. It is given in the question. Now the main aim is to solve this equation. So for the solution, how to find out the solution of this equation? See, 1 angle delta minus 1 angle 0 equals to 1 angle phi. If you convert the rectangular form into the polar form, you will get 0.8 angle 88.57, 0.8 angle 88.57 plus 5, and you can write 1 angle delta in this way, cos delta plus j sin delta, and 1 angle 0 can be written as 1. You can write this in this way, cos delta minus 1 plus j sin delta equals to 0.8, 88.57 plus 5. Take the magnitude of the left hand side term, cos delta minus 1 square plus sin delta square under root equals to 0.8 square. So it can be written as cos square delta plus 1 minus 2 cos delta plus sin square delta equals to 0.8 square. So I think I have done something wrong here. Square will not be here. The magnitude of the left hand side term will be under root cos delta minus 1 square plus sin square delta equals to 0.8. 0.8 is the magnitude of the right hand side term. So if you want to cancel this root term, take the square of left hand side term and the right hand side term, you will get this equation. Cos square delta plus sin square delta will be 1, and 1 plus 1 will be 2, so it will be 2 minus 2 cos delta equals to 0.8 square. And after solving this, you will get the value of delta equals to 47.16 degree. So this is the load angle at which the machine is operating. Put the value of delta here. Put the value of delta here. So this equation will become 1 angle 47.16 minus 1 equals to, if you calculate this right hand side part, it will be 0.8, 88.57 plus 5. If you solve the left hand side part, convert the left hand side part in the polar form, and you will get 0.8 angle 113.58, and the right hand side is equal to 0.8, 88.57 plus 5. If you compare the angle of left hand side and the right hand side, it will be 113.58 equals to 88.57 plus 5, and in this way you can write the value of phi equals to the value of phi will be equal to 25.01 degree. So in this way we can write the value of the armature current. Armature current is 1 angle phi, write the value of phi. So it will be 1 angle 25.01 degree. So if you draw the phasor diagram, this is the terminal voltage and the EMF is 1 angle delta, and delta is 47.16. So the EMF will be here, internal EMF. The angle between the internal EMF and the terminal voltage is 47.16 degree, and the current is leading. So this is the current IA, and the angle here, this angle is 25.01. So easily you can see that IA, the armature current, is leading with respect to terminal voltage. So the power factor of this machine is leading, and the value of the power factor equals to cos phi equals to cos 25.01 equals to 0.9062, and it is leading. So if you see the solution, the printed solution, if you see the printed solution, here it is written the power factor is 0.9062 leading. So the same thing I am getting in my solution, 0.9062 leading, and the load angle of the machine is 46.74, and I have got 47.16 degree. So there is somewhat deviation in my answer and the printed answer of the book. So I think there is somewhat deviation, and you can ignore it because the power factor which I have calculated is same which I have got here. So in this way the solution of example number 5.16 is complete. This is given on page number 600 of the book Electrical Machinery, written by Dr. P.S. Bimbhra.